Good morning. This is Mr. Herman here on your remediation day for tables of linear functions. And we'll go through the pretest questions here. So our first question we're looking at is the table a linear function, and explain how you know. So we're going to kind of use the ideas that we had on the exponential table video and look at our first difference and second difference. So if I'm looking at my first difference, now we got to be a bit careful here. Because if I'm looking at this one right here, I have negative 5 minus 3. But I also have 4 minus 2. So I have negative 5 minus 3 divided by 4 minus 2. It's going to be negative 8 over 2, which is negative 4. Now let's take a look at the next pair. So we have negative 9 minus negative 5. And then up top we have 5 minus 4. Okay. Let's see. So we got negative 9 plus 5 is negative 4 over 1. So we get negative 4. And then we're going to kind of stretch over here and hit negative 25 minus negative 9. 9 minus 5. Divide by 9 minus 5. And then we're going to go ahead and add our 9 there. Let's see, we get negative 16 divided by 4 gives us negative 4. So yes, this is a linear function because all of our rates of change are the same. So that constant rate of change tells us that we have a linear function. So go ahead and take a look at number 2 and see if you can identify if that's a linear function. So let's go ahead and check it. So let's take a look at our first difference. Conveniently, these are both 1 up here. 2 minus 1. So we've got negative 3 minus negative 9 over 2 minus 1. Negative 3 plus 9 gives us, let's go negative 6 over 1, so negative 6. Let's check here. Negative 1 minus negative 3 over 3 minus 2. We get 2 over 1, which is 2. So this is not a linear function because our rates of change are different. Okay, the key thing with a linear function is that we have a constant rate of change. Let's come on down to finding the slope and the y-intercept of each linear function. Okay, so our slope, we're going to go ahead and, so we're already told that these are linear, so we just have to find the slope here. So if we think back to finding slope, we have x1, x2, y1, y2. Okay, so we said m equals y2 minus y1 over x2 minus x1. And then let's go and plug in what we know. So we know that y2 is negative 5. Y1 is 3. Let's see, we got x2 is 4 and x1 is 2. So we get negative 8 in the numerator over 2. So negative 4 is our slope. Now our y-intercept is a little bit trickier. So we have 2 here, but we need to go backwards. So if we are going backwards here, that means that we are going to go towards 1. So we're getting smaller. We're going down 4 to get to negative 5. So we go up 4. So we go back 1 and up 4. We have 7. Back 1 up 4 is 0, 11. Okay, so our y-intercept equals 11. So go ahead and work out number 4. All right, so let's go ahead and take a look here. Our slope, let's go ahead and just do the same thing. x1, x2, y1, y2. Plug into our slope equation. So 0 minus negative 2 over 2 minus 1. 2 over 1 equals 2. So there's our slope. Now we need to go backwards. So 0. So if we were going up 2 as we go to the, as y moves forward, we go down 2. So we're going to go minus 2 is going to be negative 4. So our y-intercept is negative 4. All right. So let's now write a linear equation for each table. So the convenient thing is that these tables already match, and so we already know the slope and the y-intercept. So if we think back to our slope-intercept form, you know, y equals mx plus b. Okay. So we said for number 5, m equals negative 4. And our y-intercept, we said it was 11. That's the same as b. So we're going to go ahead and go here. Y equals m, negative 4, x plus b, which is 11. And then there's our equation for number 5. Let's go ahead and work out number 6 on your own. So once again, this table is the same as the table that we had above, so we can just take the y-intercept and the slope that we already found. M equals 2. Y-intercept is negative 4. We can say b equals negative 4. And then we'll use our slope-intercept form that we had above here. Y equals 2. X plus negative 4. You could also write y equals 2x minus 4. Okay, so go ahead and work on the tables of linear function notes on the back side of this before we get to your post test at the end of class today.